Hello everyone. Thank you for joining our webinar today. My name is Jared Trotter. I'm one of the application engineers here at Concepts in Production, and today I'm going to be going over animating with Solidworks Motion Study to show you guys what some of the capabilities are with this add-in. So to start off with, why use Solidworks Motion Study? What is it good for? Well, there's three things that I want you guys to walk away from this webinar with when you think about the usefulness of Solidworks Motion Study. The first of which is that you can visualize your products better with Motion Study. We all know that being able to visualize a product in 3D is already a step up from two-dimensional CAD drawings. But when you can make those three-dimensional parts and assemblies move in the way that they would in the real world, then that adds an extra element to being able to see your components actually in action and what they would look like. The next advantage of Motion Study is that it gives you some simulation capabilities. Now, normally when we talk about simulation in the context of SolidWorks, we're talking about the full simulation package. But SolidWorks Motion Study actually does give you some capability to simulate motion and gives you some physics-based calculations. The third thing that Motion Study gives you is the ability to engage with your customers or whoever it is that you're showing these products to. Because of course, when they can see your products in motion, then that's just one step closer to them being able to actually hold it in their hand or experience it in real life. So that's an added element that Motion Study gives you. Now, in terms of how this product is actually used, I want to talk to you about three different kind of modules that SolidWorks Motion Study uses. The first of which is animation. This is kind of the first level of SolidWorks Motion Study. And what you can do in this mode is add motors or assign motors to particular components or create position key points for your components. And we'll look at how to do that. And this kind of gives you some motion that's similar to expanding and collapsing when you want to do those exploded views, but of course it adds so much more in terms of movement. Next step after animation is being able to use basic motion. Motion allows you to use those animation key points, allows you to show components moving together, but it adds in gravity and contact sets and springs so that you can have your components moving together in the way that they would in the real world with such key elements as gravity. And then the last little module that SolidWorks Motion Study gives you is motion analysis. Motion analysis builds on what animation and basic motion already gives you, and it enables you to include mass and inertia in your simulation calculations. And this is available with the SolidWorks Motion add-in, and that comes with SolidWorks Premium. So we've got a few case studies to look at so that you guys can see these different modules in action. I'm going to go ahead and come over here to SolidWorks, and we'll take a look at what these can do. Well, for our first assembly, I have here is kind of this little dart gun. You may recognize it from one of the classes that you've taken with us. And what I'm actually going to start with is showing you a feature that was introduced in SolidWorks 2016, and that's Mate Controller. We'll see how we can actually use it on its own or even in tandem with Motion Study. Now, I've already got some mates that are set up here to define how this is going to move. I've got some width and distance mates set up to fully define and constrain this assembly. But as we go into edit this feature of the Mate Controller, what you're going to see is that we can actually set up specific positions using those mates. You'll see here in the property manager under the mates that there are these four mates that I just described a moment ago, the two width and two distance mates. And these are some mates that Mate Controller can use to define different positions. And a rule of thumb is that Mate Controller can use mates that have a numerical value associated with them. So obviously a distance mate has different numerical values, and a width mate as well, if you set it up to be a percentage or something like that. So you'll see as I scroll through here that these are some of the different positions that I've created where this keystroke comes out and then these darts actually come out as well. And as we scroll down in the property manager here, you'll see that there are certain amounts of time that each of these positions has ascribed to it, so that we can say how fast or how short that time takes place for this animation to go through. And as I hit calculate animation, you'll see that this goes ahead and plays through in the time that I've specified. Now, Make Controller works pretty well, and you can actually push out AVIs with that, but let's take it a step further and look at in motion study. So exiting out of Make Controller, what you would do to put into a motion study, you can just go to the Assembly tab and you'll see New Motion Study. And you can go ahead and click that, and you'll see that below this timeline shows up. This is where our motion is going to come in, and we can see at the different time segments exactly what's going on. We can then click Animation Wizard, and we can import from the Make Controller or any of these other options if they apply. Now, I've already got motion study set up, so I'll go to the one that I've established earlier. And what you would do after you brought in that motion study is go ahead and click Calculate. So calculate the motion study. And if I go back in here and just play through, you'll see we have that motion that we had there in Make Controller, but the camera is also zooming out. That's because I've assigned camera keys here. Here where you see orientation and camera views, you can set up these different key points so that at specific points within your animation, it goes to a certain viewpoint, and you can customize that, any way that you like. And as we just scroll down a little bit, I'm going to draw your attention to two things here within our timeline. One of which is these little yellow bars that we've got. These yellow bars indicate where motion is taking place for each of our different components. So if we take a look at the plunger, for example, we see that we've got a yellow bar going up here to under seconds. And if we expand that, you'll see that it's right next to the move option. So going back to the beginning, you'll see that this plunger, which is right here, it has motion ascribed to it up to that point, and then that's where the yellow bar terminates. Now, as we go down further, you'll see that we also have the mate show up here. The mate show up very much like it does in our feature tree if we were just looking at the model. But as we expand mates, you'll see that the mates have these keys that are associated with them. And that's where these mates are changing values. So for instance, this width mate is a little over 2.6 inches here. Start, it was at 0.132 inches. So motion study actually calculates the positions along this path here and interpolates it so that you get a transition, and then that's what's controlling these yellow bars here where the components are actually moving. Now, looking at this a little bit deeper and seeing some of the other capabilities you can do with animation if you want to be a little bit more creative. Let's say that you want to have multiple assemblies moving kind of concurrently. So if we go back to the model, I'll go ahead and show you right quick if we made, say for instance, a mirror image or a copy of all of these components. So I'm just going to mirror this about plane 2. Go to mirror components using this plane. I'm just going to grab all of these components. So we've got our mirror set up over here. And because these are mirror images of each other, what I can do is go back to Make Controller, and if I calculate, you'll see that both of these assemblies move together with each other because they're tied to each other. So I've got my actual positions or my Make Controller ascribed to the original, but this moves in tandem with it. And if that's how we want it to show, then that works perfectly fine. But let's say we want to offset that motion just a little bit. We need to take use of motion study in order to help us with that, or at least that's one option that we have. So what I'll do is show you that I've a little bit earlier. So these components are mirrored. I'll go ahead and delete those and show you other components that I mirrored earlier. So these components here are ones that have been mirrored, and you'll see that they all show up. That's because I've already dissolved that mirror pattern. But now that these are unsuppressed, I'll go back to the motion study, and you'll see that down here I have those mirrored components show up here as well. What I've done is unsuppressed those mirrored components, ascribe key points to each of those. So at each time frame where there's motion, I've assigned a key value to it, and then after I dissolved it, I was able to just shift all those key points over. And I did that just by doing a box select like this, and then just moving them by however much I wanted to. And so now when I go to calculate the motion study, you'll see that we have our original moving out, and then we have the second one that moves out just a few seconds behind it, so it's offset a little bit. So those are some of the things you can do in the animation module. And as we go over here right above motion study, you'll see that animation is the type of study, but we have those other two options that I mentioned, basic motion and motion analysis. So let's look at a basic motion example now. Go ahead and close out of this one, and we'll go to our next assembly. This is kind of a little Plinko board that I have set up, but Plinko with balls. And the interesting thing about this assembly is that we're going to incorporate gravity into our study. So we've got our board set up with our little pads coming out, got a little funnel, and then these balls are going to come through the funnel and then just kind of filter down here. So again, we have a motion study set up, and as we go to prepare this motion study, we're not going to be taking advantage of Make Controller in this instance. We're doing essentially everything within the motion study. Now, in order to set this up, there's a couple things that we need to do. One of which is to specify what direction gravity is in. So here on the motion study timeline, you'll see that gravity is this little button here where you can define what direction that's in. And as I go to it here in the property manager, just click on it, you'll see the green arrow right here that's pointing downward, indicating where gravity is at. And we also need to specify some solid body contacts. This lets SolidWorks know what components need to interact with each other. So as I go here to edit the feature, you'll see that all the little steel balls that I have are included, as well as the board, the funnel, and the board. So if I go to the beginning of the animation here, and I just hit play because I've already calculated it, you'll see that the balls filter down in a particular order. And it is random because if I go back to the beginning here, and let's say I want to get like a little bit of a different pattern, I can just move these balls around just a little bit, and we should see a little bit of a different result. So as I go to calculate the motion study again, you'll see that these filter down. And I think one, actually I moved it too far over from the funnel, so you see it just dropped straight downward. So you get some different results as you play with moving your components around. And as it goes through the animation, you could even do things like changing the color or the appearances of your model. So for instance, here you'll see that of course we talked about the move icon, and we mentioned explode a little bit, but you can also change your appearances and set key points for that as well. So that's basic motion, incorporating some gravity into your simulation. And the last thing we want to look at is incorporating motion analysis into our study, or taking advantage of that. So we'll go ahead and open our last assembly here. And this is a bowling lane assembly that I've created here. And this question has actually been posed before. How can SolidWorks help with doing a bowling simulation? Because when you're bowling, there's several different factors that come into play which is the amount of oil on the lane, the composition of the ball, things like that. So you may wonder, how can Solidworks help with that? So we've got a simulation set up, and I'll go ahead to this first motion study that I have. And what we've done to set this up is pretty similar to what we did for our previous motion study. One is we have to specify where gravity is going. It is pointed downward. And then we have our solid body contacts, which is between all of these different pins. There are 10 individual pins. You can see that here in the feature tree. And of course we have our ball and then our lane. I do have the lane that's fixed, very much like I had the Plinko board fixed in the previous study. And then everything else is subject to movement. So in this case, the ball, of course, is subject to movement, and the pins are subject to movement. So as we go here to the beginning of the motion study, there's one other thing that we need to specify, because we don't just have gravity at work here. We also have to apply some initial conditions to our ball. That's the main thing that's going to be moving. So what we've done is applied an initial velocity to the ball. If I go into edit the feature, you'll see what's happening. We have linear velocity that's going straight down the lane at about 20 miles per hour. And then an angular velocity also, because we actually want the ball to curve into the pins. So I'll go ahead and exit out of that, and we'll just play through the animation to see what we get here. And you'll see in this case, we actually leave the 4-pin based on our initial conditions. If we go back to the beginning of the motion study, make sure I have disabled view key creation turned off. You can kind of see it from a different orientation. Maybe we look at it straight on. And if I disable the view key creation, what I can do is delete these view keys that we have. And we can see it from this vantage point as well. Now, in order to optimize this and get a better result, what we can do is actually go right to the point right before impact and look at what happened. So as I come here and we go through a little bit more, it's probably going to change a little bit. So we see right at the point of impact, the ball is about right on that head pin. And for those who bowl a lot, you know that we need to be offset either to the left or to the right by a little bit. So we'll change our initial conditions in order to get a better result. So I'll go over here to the motion study that I have set up. And as we look at this one, I've changed the initial condition some. So we go to our feature, instead of 35 RPM, I have this set at 20. That way the ball will hit more so to the right of the head pin. Everything else is set up exactly the same. As I play through this, at this time we get a better result. We actually get a strike. I did this kind of manually, just modifying those initial conditions. What you can actually do as well is set up a design study. My study is set up so that you can optimize certain parameters within your motion study. Say for instance you wanted to say that the displacement of these pins needed to be greater than 0, and then design study would optimize your initial conditions so it would tell you the range at which you needed to roll the ball so that you could get a strike. Those are some of the things that you can do in motion analysis and with basic motion and an animation inside of a motion study. So I hope that those case studies were informative, that you kind of learned a few things about Solidworks motion study. I appreciate you guys coming and attending this webinar on animating with Solidworks motion study.